Welcome to the Microsoft Azure Data Fundamentals course. I'm Krista Santos, your Microsoft Technical Trainer, and I'll be guiding you through our journey as we explore the different data services available in Azure and how to leverage them effectively. In this session, we'll explore the fundamentals of data analytics. I'll show you why large-scale analytics matter, and we'll talk about data lakes, data warehouses, and even data lakehouses. These tools are critical for making sense of massive amounts of data, and I can't wait to show you how they work. Let's get started. So let's talk about large-scale data analytics. Imagine you're building a complex custom-designed bookshelf with secret compartments for your living room. You have all sorts of tools and materials: wood, screws, nails, glue, paints, and finishes. To craft this beautiful piece, you need to follow a plan and use a variety of techniques. This process is similar to constructing a large-scale data analytics solution. In data analytics, we deal with different types of data, formats, and sources, just like you have different materials for your project. One of the first steps is gathering your materials. In data analytics, this is called data ingestion. You collect data from places like transactional systems, files, or even real-time streams, much like gathering all the wood, screws, and nails you need for your project. Before you can start assembling, you need to prepare your materials. Maybe you need to cut the wood, sand it down, and measure everything carefully. In data analytics, this preparation process is called ETL, extract, transform, and load. It ensures your data is ready for analysis. Whether you're working with large batches of data or real-time data streams, this step is crucial, just like properly measuring and preparing your materials. Once your materials are ready, you need a workspace where the assembly happens. In the world of data analytics, this workspace could be a data warehouse, which acts like a fully equipped workshop with specialized tools, or a data lake, more like a large storage area for your raw materials. Sometimes you might use both, combining the best of both worlds in a hybrid setup. Just like you'd follow detailed blueprints when building your bookshelf, data analysts and scientists use data models to guide their analysis. These models act as your blueprint, helping you understand how different parts fit together, making the analytical process more efficient and effective. Finally, after all the hard work, you present the final product. In data analytics, this step is called data visualization. Analysts create reports, dashboards, and visualizations that reveal key insights, trends, and important business metrics. It's similar to stepping back to admire your beautifully finished bookshelf. It's not only functional, but also visually impressive and tells a story. Building a piece of furniture requires careful planning, the right tools, and attention to detail. Similarly, building a large-scale analytics solution demands a systemic approach and the right components. With everything in place, you'll be ready to unlock the full potential of your data and gain valuable insights. Whether you're building furniture or crafting a data solution, having the right tools and plan makes all the difference. Now that we've explored the steps involving preparing and analyzing data, from gathering it through ingestion to transforming and loading it into a workspace, let's dive into how these processes actually get powered. Just like a chef needs the right kitchen equipment to execute a recipe perfectly, your data processing needs the right engines to handle the heavy lifting of crunching through massive volumes of information. In data processing, having the right engine is crucial for efficiently managing and analyzing large volumes of data. These engines handle essential tasks such as data ingestion, transformation, and querying, and they're designed to operate in distributed architectures. One of the foundational tools in data processing is the relational database. These databases are like well-structured recipe books, reliable and organized. They've been around for years and are widely used for data-related applications, including large-scale analytics. Relational databases excel at processing structured data, often using SQL queries. For instance, if you're working for a financial institution and need to analyze transaction data from millions of customers, relational databases allow you to efficiently filter, aggregate, and analyze those transactions. This helps uncover patterns and trends such as potential fraud or investment opportunities. However, as data volumes grow and become more diverse, especially with unstructured data or semi-structured data, more flexible and powerful tools are needed. This is where distributed processing engines like Apache Spark comes in. Apache Spark is an open-source framework designed for handling massive datasets, making it highly scalable and versatile. Spark distributes workloads across multiple worker nodes, which makes it highly effective for complex transformations and queries. One of Spark's strengths is its ability to handle both batch and real-time processing. For example, it can process streams of social media data, such as tweets, posts, and comments, helping organizations analyze trends, identify customer sentiments, and respond to shifts in real time. These capabilities are invaluable for companies looking to make informed decisions, improve marketing strategies, or enhance customer engagement. So whether you're working with structured data in a relational database or handling large-scale diverse datasets with distributed processing engines like Apache Spark, the right data processing engine plays a crucial role in managing data efficiently and driving valuable insights. As we've explored how engines like relational databases and Apache Spark power through data processing, it's important to remember that the data itself needs somewhere to live, organized, accessible, and scalable. The way we store data is critical to how efficiently we can analyze it. Now, let's shift our focus to the different ways we store and manage data, each suited to specific types of workloads and data. Think of a data warehouse like a perfectly organized supermarket. Every item is placed in specific aisles and sections, making it easy to find exactly what you're looking for. In the data analytics world, a data warehouse functions similarly. It's a type of relational database designed specifically to store data in a way that's optimized for analytics instead of day-to-day transactional operations. Here's how it works. Data from various transactional systems is transformed and denormalized into a structured format. This structured schema is like a detailed store layout where central fact tables contain numerical data and dimension tables represent entities that allow the data to be sliced and diced. For example, imagine you're running a chain of restaurants. Your sales data could be organized in a facts table and aggregated by dimensions like menu items, location, or time. This schema is often called a star schema because it radiates outwards from the fact table to the related dimension, like a star. Now let's compare this to data lakes, which you can imagine as a vast storage warehouse for a construction company. In this warehouse, materials aren't meticulously organized like in the supermarket. They are stored as they come, ready to be used in all sorts of projects. A data lake works similarly. It's a place to store data without needing a rigid structure or predefined schema. It typically uses a high-performance distributed file system to store large volumes of raw, unstructured, or semi-structured data. For instance, imagine you're managing a video streaming platform. You're collecting data on user preferences, viewing habits, reviews, and even metadata about video files like subtitles or formats. This data doesn't fit neatly into a traditional structured format. In this case, a data lake allows you to store all these different types of data in their raw format. When it's time to analyze the data, you can apply a schema on read, meaning you can organize the data when you need it. Technologies like Apache Spark or Hadoop help dynamically process and analyze this data. But what if you need the benefits of both a structured system and the flexibility to handle raw data? That's where data lakehouses comes in. Imagine it as a modern garage with neatly organized toolboxes for specific tasks, but also space to store larger, more versatile equipment. A data lakehouse combines the flexibility of a data lake with the structured querying capabilities of a warehouse. It stores raw data like a data lake, but introduces a relational layer that organizes this data into tables, allowing you to use SQL for queries. Let's say you work for a logistics company, handling vast amounts of tracking data, vehicle telemetry, and customer orders. A data lakehouse allows you to store all this raw data while still providing the ability to run structured queries on specific data sets like tracking customer deliveries or analyzing vehicle performance trends. To recap, data warehouses are like well-organized supermarkets designed for structured data and efficient analysis. Data lakes are like a construction warehouse offering flexibility for storing unstructured or semi-structured data. Data lakehouses act like a modern garage combining the best of both worlds, allowing for flexibility while keeping data organized for analysis. Each storage solution serves different needs, from structured analytics to handling diverse data. Now that we've explored different types of data storage solutions, data warehouses, data lakes, and data lakehouses, and how they serve distinct needs, let's shift our focus to the cloud services that power large-scale data analytics. When it comes to handling large data workloads, platform as a service and software as a service offerings provide the necessary infrastructure to manage, process, and analyze data efficiently. Let's start with PaaS. One of the key PaaS offerings in Azure's analytics ecosystem is Azure Databricks, a cloud-based platform built on Apache Spark. Azure Databricks is designed to handle large-scale data engineering, data science, and machine learning workloads, all within a distributed framework. Think of it as a flexible workspace where you have all the tools to manage complex analytics, but with the scalability to handle even the largest data sets. For example, imagine you work in the automotive industry, analyzing vast amounts of telemetry data from connected vehicles. Azure Databricks makes it possible to process and transform this data quickly, enabling you to run advanced analytics to predict maintenance needs or improve vehicle performance. Its ability to integrate with other Azure services like Azure Data Lake Storage and Power BI allows you to build end-to-end analytics pipelines, giving you insights into driver behavior, fuel efficiency, or engine performance. What sets Azure Databricks apart is its collaborative capabilities. It offers an interactive workspace where data engineers, data scientists, and analysts can collaborate in real time using notebooks. This makes it easier for teams to explore data, share insights, and develop machine learning models together. And with built-in support for Spark, Azure Databricks ensures fast processing across massive datasets, making it a strong solution for both structured and unstructured data. Azure Databricks provides a flexible, scalable environment for tackling complex data challenges. Whether you're working on data engineering, building machine learning models, or processing real-time data, it provides the tools and infrastructure to manage the entire analytics process efficiently. It's ideal for organizations that need the power of distributed computing and the flexibility to customize their analytics workflows. Before diving into SaaS, let's differentiate between PaaS and SaaS with a simple example. Imagine you're setting up a coffee shop. With PaaS, you're given an empty cafe space and you get to choose how to set up the equipment, furniture, and overall design. You have more control and flexibility, but also more responsibility for setting things up. That's like Azure Databricks, where you have the powerful tools and the flexibility to build your analytics workflows exactly how you want. On the other hand, SaaS is like being handed a fully furnished, ready-to-go coffee shop, complete with everything you need to start serving customers immediately. It's convenient, requires less setup, but you might have fewer customization options. SaaS simplifies operations by giving you everything pre-configured, much like Microsoft Fabric, which is a fully managed service designed to simplify your analytics tasks. So while PaaS solutions like Azure Databricks offer flexibility and control, sometimes you need a more streamlined, fully managed solution like Microsoft Fabric. Microsoft Fabric is a comprehensive SaaS offering that unifies data integration, storage, and analysis in one platform. It simplifies the entire pipeline, from ingestion to reporting, allowing organizations to focus on extracting insights without dealing with complex infrastructure. Imagine you're running an online learning platform with data on student performance, course interactions, and content engagement spread across multiple systems. Instead of stitching together different tools and services, Microsoft Fabric lets you manage everything in one place, streamlining the process and reducing complexity. At the heart of Microsoft Fabric is OneLake, a centralized repository for storing all your data. Think of it as a digital workspace where all your data assets, whether structured or unstructured, are stored and easily accessible. The lake-centric architecture means you don't need to worry about data duplication or siloed systems. Instead, your data is available in one unified location, allowing both data teams and business users to collaborate on projects seamlessly. This setup is especially beneficial for organizations needing a single source of truth for their data. Microsoft Fabric's integration with Power BI makes it easy to create interactive dashboards and reports, enabling decision makers to access data-driven insights without the need to manage separate infrastructure components. Microsoft Fabric and OneLake offer a streamlined SaaS solution for organizations looking to simplify their analytics landscape. By providing a fully managed integrated platform, Fabric removes the complexity of handling separate services, allowing teams to focus on analysis and decision-making. For organizations seeking efficiency, ease of use, and collaboration, Microsoft Fabric is an excellent choice for scaling analytics while minimizing operational overhead. All right, so for this demo, we're going to be doing in Microsoft Fabric. I'm already logged into Microsoft Fabric here. And what I'm going to do is I'm going to switch to the data engineering experience right here. Okay. And in the data engineering experience, the first thing we're going to do is actually create a workspace. I'm going to go to Workspaces and I'm going to click on New Workspace. I'm going to create a new workspace called DP-900, for example. And in the Advanced section, I'm going to make sure that my trial is selected so that I can actually create some analytical stores. You need to have at least a trial license for this. And I'm going to hit Apply. All right, so this is our new workspace. It's completely empty. Let's create a new lakehouse in here. So for that, I'm going to click on the plus new item and I'm going to search for the lakehouse. Let me see if I can find it. And there you go. This is my lakehouse. I'm going to hit on the lakehouse. And let's give this lakehouse a name. I'm going to call this lakehouse DP-900. And click Create. And here you go. We have our new lakehouse. It has the table section, as you can see here, and the file section. This is my data warehouse component of my lakehouse, and this is my data lake component of my lakehouse, right? Currently, it's completely empty. You can see I have nothing in there. So let's try to get some data into our lakehouse. So for that, I'm going to go to this Get Data button right here. And I'm going to click New Data Pipeline. And I'm going to call this pipeline Ingest Data. And hit Create. All right. So it's directly opening the copy data activity for me to get some data in here. Here, I'm going to be selecting the sample data option to get some sample data into my lakehouse. So I'm just going to click sample data, and I'm going to select this New York taxi green data. And it has only one data set, so I'm just going to select this data set. I can wait for the data preview to load so I can see what the data looks like. Or I can just do that when I have my data already processed in my lakehouse. So let's not waste time here waiting for this data preview. Let's go to the next step. And in here, I'm going to add this to my table section. And let me just do that again. And there you go. And then I'm going to load this to a new table. And I'm going to call this new table taxi rides. Sorry, that has to be an underscore, so taxi rides. And you can see it has already generated some column mapping, so my schema is all good. And I'm going to leave this enable partition unchecked because I do not want any partitions right now. So I'm going to click next. And then over here at the bottom, make sure that I have selected the start data transfer immediately so I can get that data moved into my lakehouse immediately. Let's say no, keep as is, and save and run. So now I've created a copy data activity using the copy data guide. And I just have to wait for this data to load. Let's check out and monitor this. I'm just going to bring up this blade and you can see the status of this activity. So you can see it was previously queued. Now it's in progress. And soon it will have successfully completed. So I'll give it a couple of more seconds. It's not going to take too long. If you want to monitor this in more detail, you can also go to that activity and it opens up this page where you can see exactly how much data is being read and being processed. So you can see right now it's a little bit slow because it has not read or written any files, but there you go. You have some data coming in. It has read some data from a blob storage. And soon it will have some data written as well. We are moving 291 and 300, 291,300 rows from this source to the destination. Oh, there you go. It's updated. So we actually have 3 million rows right now, not only 291,000. And it keeps increasing because that's the number of rows that it's written. The pace is pretty good. And then you can also see the duration breakdown here, how much time it was spent in the queue, how much time in the transfer, how much time in listing the source, and how much time from reading from the source. All right. In the advanced section, you can see if this was manually triggered or triggered via a schedule. So you have a lot of details here in the activity details itself, right? It says copy data details because this is a copy data activity. So let's close this, and I'm going to refresh this a little bit more, taking a little bit of time because it's actually pretty a huge amount of data. So let's give it a little bit, and then we'll come back to this once the data has been copied. And there we go. Our pipeline has successfully completed. It only took 11 minutes. So let's go back to our lakehouse. I have it right here. And now what I'm going to do is just click on this refresh button that you see here. It's a tiny refresh button to refresh our lakehouse now that we have some data in there. And now you can see I have this new taxi rides table, which was not there before. So in order to query the data in this taxi rides table, what I'm going to do is I'm going to switch over to our SQL Analytics endpoint. So every lakehouse comes with a SQL Analytics endpoint. So I'm going to just switch over to the SQL Analytics endpoint. All right, there you go. I do have some extra system tables and query insight tables and information schema tables, but the main table that we are interested in is this taxi ride table. So let's create a new SQL query to query the data. And I'm going to write a very simple statement here. Just going to do a select date name. I want to get the day, for example, and I want to get the average trip distance on each day. So I'm going to just do this with the pickup date time as day. And average trip distance, also another column in the table, as average distance from taxi rides, our new table. And also group by, because I want to get in each group, in each day, what is the average trip distance. So I'm going to just copy this up top here again and just paste it in my group by. There you go. Let's run this query. And there you go. I have the average trip distance for each day of the week in this entire table. Okay, so I have Tuesday, Saturday, Friday, Monday, Sunday, Thursday, and Wednesday. All right. So that you can see how easy it is to query the data warehouse part of our lakehouse. So now let's go to the model layouts. You can see it right here, model layouts. This is where we are going to make sure our new taxi rides table is in our semantic model. What we're going to do is just see if our layout has been properly created, our model layout is properly created, which means that I want to see that my taxi rides table is in here, and I can see that's exactly the case in this case. I have my taxi rides table here. Okay. So the next thing what I want to do is go to the reporting tab and click on new report. This is automatically going to try to create a new report on the default semantic model of this lakehouse. So let's take a look. I'm going to create new report, and there you go. I have my taxi rides table. Now, in order to build a report, it's super simple. I'm just going to select, for example, this line graph. And I am going to add to this line graph the pickup date in the x-axis and the sum of passenger count in the y-axis. And there you go. I have a very simple report created just by putting the pickup time in the x-axis and the sum of passenger count in the y-axis. And with that, we can save this. So I can go to File and save this report. So I'm going to save this report to my DP-900 workspace, and I'm going to enter a name for this report. I'm going to call it Taxi Rides Report. And save. All right, there you go. I have created a very simple report, and I can then also go back to my workspace and see I have this report created in my workspace. And with this, we have come to the end of this demo. I'll see you back in the presentation. As we wrap up this session, let's take a moment to recap what we've seen right now. We kick things off with the fundamentals of large-scale data analytics, diving into key components like data processing engines and various analytical data store options. Then we explored how PaaS services in Azure can supercharge your analytical capabilities and discussed the game-changing potential of Microsoft Fabric. This concludes our session. There are many ways to continue your learning journey. We encourage you to watch other videos in this course or search out your next favorite topic on Microsoft Learn at ak.ms/learn.